Alright, so welcome to our YouTube channel. In this video, we'll be revising, rather, we'll be solving a mathematics past paper, which is paper 2, which was written in the year 2022 by the internals, which was written in November. So specifically, we'll be looking at question B2, question 3A, and 3B. Those are the questions we'll be looking at specifically in this video. But if you want to see the full paper being solved, you can like our video and subscribe to our YouTube channel, which is One Step Academy. Okay, so without wasting much of your time, we can look at the first question we're going to do in this video, which is question 2B, which was specifically on vectors. Okay, so you'll find that vectors are mostly found in papers, or in past papers rather. Okay, so you need at least to have full information on how to go about vectors. They are very simple. It is not a topic that is really involving. It is a very, very simple topic. So, the question is saying, in the parallelogram OABC, OA is equal to 4 vector A, OC is equal to 6C or 6 vector C. AP is equal to 2/3, rather 2/3 of AC. And M is the midpoint of BC. Okay, so sometimes it is very important that you understand the full concept in the question. That is very, very important. Since they're saying this is a parallelogram, and a parallelogram is more of like a square, which means two sides, okay, these two opposite sides, they are equal. Okay, so if OC is equal to 6 vector C, even AB should be equal to 6 vector C. That is one point, because that is a parallelogram, so it's more like of a square in short, or let me say a rectangle in short, because we're having two opposite sides which are equal. Same applies to this other side. Since OA is equal to 4 vector A, which means even CB or BC is also equal to 4 vector A. That is it. Okay? So you need to understand these things very carefully. Okay? You need to really understand. So, after understanding this, you can find that the first question is saying, find in terms of vector A and or vector C. Okay? Okay, so after understanding that, okay, so we can now find the root AC. Okay, so mind you, looking at this question, the root is trying to point in this direction, which means we're moving from A going to C. So you go on the diagram now, they are saying you move from A, you go to C. Okay, quite alright, you can use this part because this parallelogram, it's every side that side is having a root. Okay, so if you want, you can say AB plus BC. But the simplest way to do this, you just say A, or if you want to move from A going to C, you're going to say A, O plus O C, which means we have arrived at C, coming from A. So we can write our formula, very important. So I'm going to say, let's say this is A. Then we say AC. This root AC, okay? Root AC will be equal to, we'll first start from A, then go to O, okay? We'll first start from A, then go to O. Then from O, we'll go to C. So I'm going to say plus O, C. One thing that you need to realize is that when you're writing such formula, you'll find that always these two letters are common. Then these two letters this side, they represent what is it. This is your starting point and this is your destination. Okay, that's one thing that you need to really put into consideration if you're dealing with such questions. And then now we can now say AC is equal to AO. AO. So this root here, it is OA. Looking at the arrow here, this arrow is pointing this side. So this root is OA. But us, what we need is AO. So it's like we are opposing this direction of the root. Okay? We are opposing the direction. So, which means we need to write this vector in inverse form, or the negative of that. Okay? Which means AO will be equal to negative 4 vector A. Okay? The reason why I'm putting a negative, it's because I'm opposing this direction. Okay? Once you oppose the direction of a root, then that vector will be in a negative form. Okay? So, we're going to proceed and say plus OC. What is OC? OC, we are not opposing this direction. So it will be in positive form because we are not opposing this direction. So OC is equal to 6 vector C. Okay? Now, according to the principles of the laws of mathematics, we are not supposed to leave an equation with a negative sign. Okay? Quite alright. They will mark you if you leave that answer there, but you should be more mathematical. Okay? So you just interchange, or you just simplify here. Okay? By saying AC is equal to this comes inside, the other one goes that side. So it becomes 6 vector C, then negative 4 vector A. I've not changed anything there. Okay, and some teachers you find that they'll tell you to say, here simply because there's something common you can factorize. They'll also mark you. Okay, when you factorize, they'll also mark you because there too is common, so you can factor out. Okay, you can factor out something like this. Well, by saying 6C, negative 4, like that. So you can factor out, you say 2 is common. 2 into 6, that is 3C. Then negative 2 into 4, that is 2 vector A. Okay? You can leave it like that, or like this is one and the same. Okay? Some teachers will just be more specific to tell you that if there's something common, you can factor out. Okay? That is it, but there's no need of doing that. It's just one and the same, because when we multiply out through, you'll find that we'll get back to the same answer. So that is our AC. So we found AC. So AC is equal to 6 vector C minus 4 vector A. That is it. Okay. Then after that now, okay, after that we are going to go to B. B is saying we find the root OP. Moving from O going to B. So we can say B. B is saying we move from O, we go to P in that direction. Okay, so we need to go back to our diagram and say, we look at what is happening here. So I'm going to say OP, this part here, or this root here. So we can find OP by saying OC, take note, OC plus CP. You can also say OA plus AP. Now, when you find that you're having two methods that are trying to find that root, you need to just go for the simplest. Okay, instead of you wasting time and stressing. Okay, you can find that CP. It will take time for me to find the CP. But AP, okay, AP has been given in the question. That's saying AP is equal to 2/3 or 2/3 of SC. So, which means I can use AP because the root AP has been given in the question. Okay. No wonder I was saying sometimes you find that the answer is just hidden in the question. No wonder you first really need to understand what the question is talking about. Okay. So I'm going to say OP. So OP. I'll move from O to A, then from A to P. Because I have this AP. It is in the question. And even OA, it is there. Okay? So I'm going to say OP is equal to OA. You show the direction of the root. OA plus AP. As I what is here. Okay, so that finally we can say OP. OP is equal to, what is OA? What is OA? We are not opposing this direction. We are not opposing this direction. So OA is equal to 4 vector A. So we say 4 vector A plus AP. AP has been given in the question here. They're saying AP is equal to 2 over 3 of AC. Of in mathematics means multiplication. Okay, so we are going to say AP is equal to what? We just get what is here. We'll just say it is equal to 3 over 2 of what? AC. And mind you, we already have AC. In the previous question, we found AC. Okay, so we just factor out and simplify that by saying OP is equal to 4 vector A plus 2 over 3 or divided by 3. Then what is AC? You open brackets. When you're replacing in mathematics, when you're replacing letters or a letter by its value, make sure that you introduce brackets. That will help you because we're talking over multiplication. So AC that is the one which we found in the previous question. It was 6 vector C negative 4 vector A. This was AC. Then you can simplify or you can multiply throughout by saying this will just come like that. You say plus 2 by 6, okay? 2 by 6, that is 12 vector C divided by the dividend, which is the divided by, which is 3. The divided is 3, okay? Then we say minus 2 by 4, which is 8, okay, which is 8. So we say 8 vector A divided by 3, okay. What I advise is this: if these letters which are inside there, they are unlike terms, don't use one denominator, because you find that someone will tell you to just say multiply throughout and just divide by 1 3, whereby it was supposed to be like this, something like this, when like that. Then you say over 3. No. These are like terms, so make sure that you separate them so that you will collect the like terms. Okay? Make sure you separate them. Don't do this. This is not advised. Okay? So we are going to say now, since we've tried to deal out with what was in the brackets, we can now just collect the like terms. We can insert this one and this one. They are like terms. So we're going to say OP. OP is equal to, we start with the actual, which is 4 vector A minus 8 vector A divided by 3. Then this one, which is positive 12 vector C divided by 3. Then you can balance here, you make it a fraction. Okay? Because there's a fraction here, and we also need to make that one a fraction. Now, we only look for the common denominator if the numerators are common. So here the numerators are common, so we can find the common denominator. So I'm going to say our OP in this case will be equal to, okay, our OP in this case will be equal to, what is the common denominator here? The common denominator is 3. How many times can 1 go into 3? 1 can go into 3 times. 3 by 4, that is 12. So it's a 12 vector A minus 3 into 3, that is 1. 1 times 8 vector A, that is 8 vector A. Okay, then this one is still plus 12 vector C over 3. So that we can now say OP is equal to 12 vector A minus 8 vector A. It's just like saying 12 minus 8. 12 minus 8, that is 4. So we have 4 vector A over 3, or divided by 3, plus 12 vector C divided by 3. Okay? So here, please don't find the common denominator, because these two numerators, they are not common. So that becomes your final answer. We shouldn't be misusing mathematical principles. Okay? So we cannot find the common denominator there because the numerators are not common. So our final answer becomes OP is equal to 4 vector A divided by 3 plus 12 vector C divided by 4. By 3, sorry. Okay, that is our OP. Then for C that said we find OM. Okay, we find OM. So let's recognize OM. It is very important in mathematics to recognize what we are talking about. You need to recognize that. Okay, so what they need here is OM. Okay, OM is right here. This is O and this is M. Okay, so they want us to move from O, we go up to M. So one thing that you need to understand is that M is the midpoint. Okay, since it is the midpoint, which means this part CM is half of the whole thing. Okay, which means if, like for example, in fact, this root we have said it is 4 vector A. Since it is 4 vector A, which means from C to M we have 2 vector A. Even from M to B we're having 2 vector A. So at 2 vector A plus 2 vector A, 4 vector A. That is the principle, because that is the midpoint. Okay, since it is the midpoint, these two are half. Okay, this one is half of this one, even this one is half of this one. Okay, so if I want to move from O to M, I'll just say O C plus C M. As simple as that. That is my OM. So I'll say O M. OM should be equal to O C. So we say O C plus what? C M plus C M. As usual, these two letters should be common. Then these two letters should represent what is this side. So that we're going to say now OM. OM is equal to, let's hope this is visible. Okay, let me do it from the other part in case it is not visible. Let me do it from the other part. Okay, so let's do it from here. Okay, we'll do it from here. So we're saying OM is equal to, we say OC plus CM. Okay, so that finally OM is equal to, what is OC? We are not opposing this direction. So it will still be 6 vector C plus CM. We are not opposing this direction. This direction is going like this. Same applies to this end. So plus, which is 2 vector A. So we say 2 vector A. Okay? 2 vector A. So as I told you, sometimes or some teachers will tell you to say you factorize that. So you can factorize, and some teachers again like me will tell you to when you're trying to find vectors in such a way like here, whereby I have C and A, you try to follow the alphabet, okay, according to the arrangement of vectors. So you can just say therefore OM is equal to, you just start with this one. You're just trying to simplify or to just follow the arrangement, okay? So vector A, positive vector C. Why I've done this, I've just tried to follow the alphabetical order. A is before C. That is what I've done now, okay? Yeah, so that is it. So that is our OM. So OM is equal to A plus 2 vector A plus 6 vector C. As simple as that. Then the last one, number 2. They're saying hence or otherwise show that the points OP, and M are collinear. Okay, so when they say collinear, which means these lines they're talking about, okay, they're saying collinear. It means the lines they're talking about, they are parallel to each other, or they're having different magnitude, same magnitude. Okay, like for example, let me do this. If I have these two lines like this, so this line and this line, they are parallel to each other, which means they are equal in some ways, or they're having something common. Okay, but the only difference between this line and this line is the magnitude. Okay, or the length in short. This one can be maybe, or this one can be maybe 3 vector B. Then this one will be maybe 6 vector B. Okay? So which means there's something common there, but it's just that the magnitude is the one which is different. Okay? The magnitude is different. Or same applies to lines which are like this. Okay? Sometimes you might have something like this, whereby you have a line like that and this one like that. So if this one is 2b, even this one is 2b, they're having the same magnitude. Okay? They're having the same magnitude. So which means they're parallel to each other. Okay? So this is what it means that when they say collinear, they're trying to talk about parallel. Okay? When we say, in short, let me use this term. Collinear means these points they're talking about, which is O, P, and M, they lie on a straight line. Okay? A straight line, that no wonder I'm using parallel, it's just one and the same. Okay? So, parallel, okay, they are parallel or they lie on the same straight line, or they are in a straight line. Okay? They are in a straight line. That's what it means. So, for us to do that, we need to prove one thing, or we need to identify something. So, since they're saying O, P, and M, so this line, like this, if I have to extend like that, okay, we need to show that this is a straight line, or these points are trying to lie on a straight line. So, what I need to do is just to make sure that I have all the points here. Okay, like for example, this point from here up to here, which is OP. OP, I've already found OP. OP is here. Then, OM I've found, which is here. So the only thing that I don't have is the line from here up to here, which is PM. I don't have that one. So if we find that one, we'll try to find out that there is something common amongst those 3 points. Okay? For those 3 lines. Okay, we have this one from here up to here, then from here up to here, and the whole thing which is from here up to here. There's something common. So let's make sure we find PM, which the one which we don't have. Okay, we already have OP and we already have OM. What we only don't have is PM. Okay, so let's find PM. So I'll use this part. So I'm going to say PM. PM will be equal to, from P to M, we can say POOCCM. Okay, like we're moving in that direction. Okay, so I'm going to say PM. We're going to move from P to O. Okay, from P to O, take note, from P to O plus from O to C plus from C to M, which means I've moved from P to M. And you can see that here you're having the last letter becomes the first letter here. The last letter becomes the first letter there. Okay? So let's find that one. So I'm going to say PM. PM will be equal to, what is PO? Okay? What is PO? From P to O here. So PO, we found this is OP. So it's like the opposite. The opposite of OP is PO. Okay? This is OP. This is OP. Take note. This is OP. This is the crucial part. Okay? You really need to take note. Okay? The one which we found is OP. OP. But what we need is PO. So it's just the opposite. Okay? So which means, if I want to find the opposite, which means PO will be equal to negative or the opposite of OP. That's how it is. Okay? That's the opposite. It's the opposite. Okay? We need to take note of this. So that if you want to find PO, you will say PO. PO is equal to, what is OP? OP is 4 vector A over 3 plus 12 vector C over 3. Then get rid of the brackets. There's a negative, mind you, here. There's a negative. So multiply throughout using a negative, so that PO is equal to negative by positive, so it becomes negative 4 vector A divided by 3. Then negative by positive also becomes a negative, so negative 12C over 3. So this one is PM. That is what we're supposed to use here. PO, take note, not PM. PO, take note, PO. Let's hope it is visible there. Let's hope so. Let's hope you can clearly see there. Yeah, we do something like this. Okay, yeah, something like that. Hope it is visible now. Alright, so since we've found PO, we're going to say PO is equal to negative 4 vector A over 3. Then negative 12 vector C over 3. That is PM. Plus OC. What is OC? OC. OC is just 6 vector C. Okay? This one which is here. Then we say plus CM. Okay? Plus CM. CM is just 2 vector A. Like that. Okay? So after that now, we need to collect the like terms. Okay? We need to collect the like terms. Let me do this a bit so that you clearly see. Okay? So we need to collect the like terms after that. So I'm going to say PM is equal to, we can start with this one. So I'm going to say, or if you want, you can start with this one which is in positive. I advise that you start with the one which is in positive. Or you start with this one and the same. So we say 2 vector A. Okay, 2 vector A. Then you say, take note. You say minus 4 vector A over 3. Then plus. If you want, you can start with a positive or a negative. It will always give you the same answer. So long as you are trying to follow the right principle. Okay. So if you want, you can say positive 6 vector C. Then minus 12 vector C over 3. Okay. So that PM is equal to, we balance here that fraction. Even there, we balance that fraction. So that we say, what is the common denominator here? The common denominator is 3. 1 into 3, it is 3. 3 times 2. 3 times 2, that is 6. Okay? So we say 6 vector N. Then we say minus 3 into 3, that is 1. 1 times 4 vector A, that is 4 vector N. Okay? Then this side we're saying plus. The common denominator here, even this side, the common denominator is 3. 1 into 3, it is 3. Then 3 times 6, that is 18. So we say 18 vector C. Then minus 3 into 3, that is 1. 1 times 12 vector C, that is 12 vector C. Like that. I hope it is visible. Okay? I hope it is visible. Now, let's proceed. Let me erase this part so that I can use it. So, after that, now I'm going to say PM is equal to, what is 6 vector A minus 4 vector A? That is 2 vector A. So I'm going to say 2 vector A. When we do that, then we say divided by 3. Okay? Divided by 3. Then after that, you can say plus 18. Okay? 18 minus 12. Okay? So that is, you find that is 6 vector C. Okay? In short, you're just saying 8 minus 2, which is a 6. So we say 6 vector C over 3. Okay? So that is our PM. Here, don't find the common denominator, because these 2 letters on top, they are unlike terms. Okay? So that is our PM. Now the question has taught us to say, we state, or saying we show that points P, O, and M are collinear. So I will conclude to say P, O, P, and M are collinear. Because if you observe now, they're having something in common. The root OP, let's go to OP. OP is here. OP is having something common. It is having A plus C. Okay? Don't matter about the numbers or the coefficients, because these are just trying to tell you something. Like, for example, what I was explaining, if you have two parallel lines like this with different magnitude, this one can be 2b, then this one can be 4b. So the numbers won't be common because they're just saying this one is twice this one. Okay, so the common thing is the letter. That is what we need. No wonder I'm saying what is common here, you only go for the letter. So here we're having A plus C for OP. Then for OM, when we go where OM is here. We also have here A plus C. Okay, excluding the numbers. We only look for the letters we check. So A plus C. Even PM, we've found PM. Even PM is having A plus C. So which means these 3 points are lying on a straight line or the collinear. So you will say the points, okay? The points, you say therefore the points O, comma P and M are collinear. Okay? Are collinear because, okay, you give a reason, because they have A plus C in common. As simple as that. And you have all your full marks. As simple as that. So we can now go to the next question, which is 3A.